Okay, today we will talk about remainder theorem and factor theorem. Tomorrow I will introduce you rational root theorem or rational zero theorem. And third day I will talk about fundamental theorem of algebra. So we will talk about 3 days or theorems. So it will be a little bit tough, and I'm going to use the general term, and then you will see, oh, what is this? But by using the same type of the problems, you will understand what I'm talking about. Okay, so we will do some same practice problems. First, the top part, and today we will talk about 2 theorems. Remainder theorem first, and when we are done front page, and I'm going to introduce factor theorem. This is simply same kind. Remainder theorem is a little bigger idea, and in one specific case when remainder is 0 is called the factor theorem. So we'll talk about those. In the theorem, and I have a polynomial f of x, and qx is going to be my quotient part. X minus a is my divisor plus something else. So this is my remainder. And this is my divisor. And this is my quotient. Looks too difficult, right? Let me do easy example. Okay, let's see. 10 divided by 4, what do we get? 4 times 2, 8, remainder 2. I'd like to avoid the same number, but anyway, I got the same thing. So you can rewrite 10 equals quotient 2 times divisor 4 plus remainder, right? That's how I write it. In any polynomial function can be written as quotient times divisor plus remainder. It's in the box on your handout. So that is the meaning, and the theorem says the remainder when you divide the polynomial by this divisor is the constant f of a. So I'm going to divide by a. That means I'm going to plug a here, right? If I put a here, what do you get? A minus a will be 0. Whatever you get, this will be 0. Okay? 0 times whatever, what do you get? Everything will be 0 here. Okay? So the theorem says f of x is going to be same as f of a when you plug 0. So I'm going to write this way. Your function value at x is going to be the same as your remainder. So this is called the remainder theorem. Okay, open your eyes and let's do one example with me. So for example, I'm going to do the same example on your paper. 3x fourth power 2x cubed minus 5x squared plus x minus 2. And the question is, find f of negative 2. Let's say I'm going to teach this one to my Algebra 1 students. I don't have those, but let's assume, okay? What they are going to do if I teach this? They don't know remainder theorem at all, so they will just plug the number, right? F of negative 2 is 3 times negative 2 to the 4th power plus 2 times negative 2 to the 3rd power, subtract 5 times negative 2 to the 2nd power plus negative 2, subtract 2. Phew! So 2 times 2 times 2 times 2, 16, and then multiply, and ooh. After all, you will find your answer. Oh, that's 8, like that. This is called the direct substitution, right? We know this one very well. You can find the same answer by using remainder theorem. Remainder theorem says find the remainder using the divisor. So what will be my divisor? Negative 2. So I'm going to do long division or synthetic division? What do you prefer? Yeah, I prefer synthetic division here. So I got all the numbers. Where do I have these numbers? Quotients, right? Coefficients. Coefficients are the numbers I chose here, okay? If I have no place value, I need to leave 0 there. So I'm going to do synthetic division. What will be my number? I'm using the same number here to do it. -2. Alright, bring down first number. Multiply crossway. Multiply -2 times 3. Product is -6. And then top and bottom add. -4. Crossway multiply -2 times -4. 8. Top and bottom add. Multiply -6. Add. -5. Multiply 10. What is my remainder? 8. See? I got the same number. I direct substitute, or I use the synthetic division to find the remainder using this as my divisor, and I get the same answer. This is called remainder theorem. Your remainder will be same value of the function value when you use this number as your divisor. So which one would be easier? Sometimes direct substitution is easy because number is smaller, but sometimes instead of keep multiplying, you may think about doing synthetic division to get answer quickly. Okay? So remainder is same as the function value. That is the remainder theorem.